In this example, we have to find the integral of x upon x raised to 4 plus x square plus 1. तो यहाँ पे हम मेथड ऑफ सब्स्टिट्यूशन अप्लाई करेंगे. सो सबसे पहले लेट अस पुट x square is equals to t. This gives us 2x dx is equals to dt and therefore हमारा इंटीग्रल बन जाएगा half dt upon x raised to 4 becomes t square. तो ये आ गया t square plus t plus 1. Now this basically is of the form 1 by quadratic, which we have discussed earlier. तो half we will take to the outside. तो ये हो जाएगा t plus 1 by 2 का होल स्क्वायर minus 1 by 4 plus 1 dt. तो यहाँ पे we have converted the denominator into a perfect square. I hope आपको पता है कि हम perfect square कैसे convert करते हैं, and we have already discussed this in many places. In integration also, in the earlier videos we have discussed this. So you can go back and look for this part. तो अभी अगर हम इसको further simplify करेंगे, so we get this half integral dt over t plus 1 by 2 whole squared plus root 3 by 4 whole squared. So now we will apply the formula of 1 by x square plus a square dx. So this we know is equal to 1 by a tan inverse of x by a. So this is the formula. तो अगर ये formula हम apply कर लें यहाँ पे, तो हमारे पास आएगा 1 by 2 into 1 by a. A is basically the constant here, which is root 3 by 4. तो ये बन जाएगा root 3 by 2 into tan inverse of x की जगह पे हमें मिलेगा t plus 1 over 2 upon root 3 by 2 plus constant of integration. So this, if we simplify, 2 and 2 will get cancelled out, and this is equal to 1 by root 3 into tan inverse of 2t plus 1 upon root 3 plus c. And if we put the value of t, we get the final answer as 1 by root t into tan inverse of 2x squared plus 1 over root 3 plus c, and that, my dear students, is the final answer. तो आई होप आपको ये समझ आया होगा कि इस क्वेश्चन को हमने कैसे सॉल्व किया. नाउ लेट अस प्रोसीड टू अनदर एग्जांपल. तो यहाँ पे हमारा क्वेश्चन है इंटीग्रल ऑफ 5x plus 4 upon under root of x square plus 2x plus 5. So this, my dear students, is of the form linear upon root quadratic. तो ऐसे केसेस में हम क्या करते हैं, हम लोग न्यूमरेटर को लिखते हैं इन द फॉलोइंग मैनर. सो न्यूमरेटर is written as lambda times derivative of denominator plus some another constant mu. तो न्यूमरेटर है हमारा यहाँ पे 5x plus 4 और ये हो जाएगा इक्वल टू लैम्डा इंटू डिनोमिनेटर में जो क्वाड्रेटिक एक्सप्रेशन है उसका डेरिवेटिव वी विल हैव एज 2x plus 2 and the constant is mu. तो if these two expressions are equal, x वाले टर्म को इक्वेट करने पे we will get the value of 2 lambda as 5, and that gives us the value of lambda as 5 over 2. And similarly, 2 lambda plus mu is the constant on the right hand side, and this is equals to 4. Since we know 2 lambda is equals to 5, तो ये आ जाता है हमारे पास mu is equals to 4 minus 5, and that is equals to minus 1. तो ये हमें lambda और mu की वैल्यू मिल गई. So now we can write this question as integral I is equal to 5 over 2 into 2x plus 2 minus 1 upon under root of x square plus 2x plus 5 dx. So we will split the numerator. तो पहले टर्म में हमें मिलेगा इंटीग्रल ऑफ 5/2 into 2x plus 2 upon under root of x square plus 2x plus 5 into dx minus integral of 1 over under root of x square plus 2x plus 5 and here we have dx. तो अभी इस क्वेश्चन को हमने दो इंटीग्रल्स के फॉर्मेट में कर लिया है और दोनों को हम अलग अलग सॉल्व करेंगे. So let us take this integral as I1 and the other integral as I2. So if we integrate I1, so we have I1 as integral of 5/2 into 2x plus 2 upon under root of x squared plus 2x plus 5 dx. Now here we put x square plus 2x plus 5 is equals to t. तो अगर हम इसको डिफरेंशिएट करेंगे तो वी गेट 2x plus 2 dx is equals to dt. तो हमारा न्यूमरेटर बन जाता है इंटीग्रल ऑफ 5/2 dt upon root t. Or we can also substitute, instead of t we can take it here as t squared. So this will give us 2t dt in the numerator. So let us change it here. So 5/2 into 2t dt upon under root of, हम यहाँ पे लिखेंगे t square. तो ये 2 और 2 कैंसिल हो जाएगा. 5 we will take outside and t and this t also gets cancelled out. So this becomes 5t. We are not adding constant of integration now. वो हम last में add कर लेंगे. And t basically here is nothing but under root of x squared plus 2x plus 5. So this is the integral to the first part. Now I2 is nothing but integral of 1 by under root of x squared plus 2x plus 5 dx. तो यहाँ पे हमने इसको लिख लिया इंटीग्रल ऑफ 1 बाय अंडर रूट ऑफ, इस क्वाड्रेटिक एक्सप्रेशन को we will convert it into a perfect square. So we get x plus 1 whole squared minus 1 plus 5 into dx, and this is basically equal to 1 by under root of x plus 1 whole squared plus 4 dx, and this is of the form 1 by under root of x square plus a square, and which, dear students, is given by the formula ln of modulus x plus under root of x square plus a square. I hope you remember. तो अगर हम इसको अप्लाई कर ले यहाँ पे तो हमें फाइनल आंसर क्या मिल जाएगा? We'll get this as log of modulus x plus 1 plus under root of x squared plus 2x plus 5, and plus, let us say, we can also write constant of integration, and here let us also write constant of integration. तो ये हो गया plus c1 और यहाँ हो गया c2. So if we now put the value of I1 and I2 back in this expression, in this equation, so what we have is the final result I is equal to 5 into under root of x squared plus 2x plus 5 minus ln of modulus x plus 1 plus under root of x squared plus 2x plus 5, and the constants that we will have is plus c1 minus c2, and इन दोनों कांस्टेंट को कंबाइन करके let us write this as c. So we can overall write the final answer as plus c, where C is nothing but C1 minus C2. And that, my dear students, is the final answer. तो आई होप आपको समझ आया होगा कि इस क्वेश्चन को हमने कैसे सॉल्व किया. सो इन दिस वीडियो वी डिस्कस्ड टू टाइप्स ऑफ प्रॉब्लम्स. इन द फर्स्ट क्वेश्चन we converted the integral to 1 by quadratic, and in the second question the format was linear upon root quadratic. So I now hope that you understand how do we approach such type of questions. So that, my dear students, is all that we have in this video. Practice all these questions. Now, my aim is to give you all the variety so that you know when to approach in which particular manner. Because integration sometimes becomes tricky and students find it a little difficult to approach the questions related to integration. So that, my dear students, is all that we have in this video.